Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how functions can be translated horizontally on a coordinate system axis. So again, the topic here, horizontal translations. So we're going to start by looking at the function y equals x squared. And I've already took the time to write out some data points. I'll leave it to the exercise of the reader here to go through and take values like confirm that negative 2 squared is 4 and so forth. If we plot these points on the graph, let's see, 1, 2, 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that one is here. All right, negative 2, 4. There's 2 left, 4 up. Negative 1, 1. 0, 0. 1, 1. 2, 4. 3, 9. And then we connect the dots here to kind of finish out our sketch. And this is a parabola centered at the origin, opens up. It's one of my favorite example functions, y equals x squared is. So here's a graph of our original function. I'm going to call it f of x. In green now, we're going to plot this. We're going to compare it to this function, y equals x minus 2, the quantity squared. Now this is some other function, which I'm going to call it g of x. But notice that this is equal to f of x minus 2. If I were to take the term x minus 2 and sub it here for x, we would get this function. Now, I went through and started plotting or calculating data points. X equals negative 3 corresponds to 25. That's off the graph. Vertically, it's up here. I'm not going to worry about that one. I'm also not going to worry about the negative 216. I'm going to start plotting it in this region, and I'm going to plot these in green. So negative 1, 9, 1 left, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 is here. 0, 4, 1, 1, 2, 0, 3, 1, 4, 2, oops, 4, I don't think that's 2 here, give me a moment here, 4, minus 2 is 2 squared. Oh, I'm sorry, that should have been 4, 4. My bad. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, and maybe one more. Let's plot it for x equals 5 as well. 5 minus 2 is 3, squared is 9. So 1, 2, 3, 4, 5, and then 9. Okay, and then we'll connect the dots. And what you'll notice is that, especially if my drawing was a little better, the green perfectly is a perfect image of the black, just shifted to the right by 2 units. And that's the effect of this minus 2 right here. In general, if I take a function f of x, no matter what that function is, and then I compare it to, let's say, f of x plus h, where h is just some number, these graphs are going to be identical, but horizontally shifted by to the right by an amount h if h is negative. Let me say to the right by an amount absolute value of h if h is negative. To the left by an amount h if h is positive. You can see here where we have f of x minus 2 resulted in a shift to the right by an amount 2. If this were an x minus 5, this green graph would have been shifted over 5 to the right. Had it been an x plus 2, it would be shifted to the left by an amount 2. So in general, if I take a function f of x and I compare it to some other function f of x plus h, these graphs will be identical, other than this one will be shifted right by an amount h if h is negative, left by an amount h if h is positive. I'll go ahead and make other videos for examples of this. I hope that this helps give you a reasonable introduction to the topic. Have a great day.